Hello, everyone, and welcome to another 10th seminar. Today we have Professor Miralinaghi. He's an assistant professor at the Illinois Institute of Technology's Department of Civil, Architectural, and Environmental Engineering. His research interests include transportation infrastructure planning, travel demand management, sustainable transportation system, and the impacts of emerging technologies in transportation infrastructure. He received his doctorate in transportation engineering from Purdue University and his master's degrees in transportation planning from the University of Alabama and Sharif University of Technology. Bachelor's degree in civil engineering from Sharif University of Technology. Help me welcome Professor. It's all yours.
Thank you. So, thanks for the introduction. Thanks for having me today here. So today I'm going to speak about our recent project that we did actually at Purdue and Georgia Tech on the scheduling of road construction project, considering different stakeholder concerns. So before diving into technical presentation, I would like to name my wonderful collaborators on these research projects: Professor Sinha, Professor Lavi, Professor Abraham, and Professor Voldemariam of Purdue University, and Mustafa Sani from Sharif University of Technology, Mohammad Miralinaghi from Purdue University, and Sania Sailavi and as postdoctoral of law at the University of Auckland. So here's the presentation outline. First, we are going to start with the background, and then we see some network level scheduling of construction project considering user and business impact. Then we see the contract bundling consideration in urban road project scheduling. Then it follows up with a methodology for scheduling within the roadway workzone using deep neural network and active learning algorithms. And finally, we concluded with some research findings and future research directions. So urbanization poses an imminent threat to the well-being of humanity right now. A major portion of population in the United States living in urban areas. And because of that, we see several problems like growing traffic congestion, emissions, and so on. So road projects are one of the main reasons for having traffic congestion. Based on the FHWA report in 2017, 10% of traffic congestion is because of the construction work zones that we see in metropolitan areas. They have several unintended consequences for road users and community. For road users, as I mentioned, traffic congestion, emissions, safety impact, noise, pollution, and so on. And the question that we try to see and address in this series of basic studies is how to optimally schedule the road project to minimize the negative impacts on road users and community. So we have the road construction scheduling as a core for this presentation. Then we see some stakeholders like transportation agency, community, and road users. There are different project types that we are going to consider, like road capacity expansion, road rehabilitation, new road construction. These three, I assume that they are going to take few months, and there is a minor road project that can take few hours. There are different delivery methods like partial or full closure, whether we should close the road fully, finish it in the shorter time periods, or do the partial road closure and take longer to finish the project. And also bundling project, if we would be able to bundle the project together, make it a larger project and carrying them out. Solution algorithms, of course, there are several algorithms that have been used to tackle this problem, like meta-heuristic. What we are going to use is like particle sum optimization, non-dominated sorting genetic algorithm, neural network, and exact method like active set algorithm. So I'm going to show like 3 studies that we did in the past few years in this area. And there will be one followed up in theory that basically you can later see. So first, I'm going to start with the first study that we did in this area, network level scheduling of construction project, considering users and business impact. The novelty of this work is about this business impact. Previously, all the research projects in this area only consider like users, total travel time, construction cost, and so on. But in this project, actually, we consider business impact, and it has the reason that why we consider business impact. I will mention that later. So the findings of this research have been published in Computer Civil Infrastructure Engineering and European Journal of Operational Research. So we see that the stakeholders that we are going to tackle are the businesses as the community and the road users. And the project types that we are going to consider are road capacity expansion and road rehabilitation. In another paper in European Journal of Operational Research, we consider this new road construction as well. And we see the exact method to solve this problem using the active set algorithm. So the construction project can cause decrease in the business revenues because there is a loss in accessibility to the location, and customers may deviate to the other areas. So in 2016, a series of road projects occurred in Lafayette, Indiana, which caused a significant revenue loss and bankruptcies for some of the business in that neighborhood, especially one of the car dealers, famous car dealers in that area, Bob Rohama, threatened to sue Indiana Department of Transportation for such a severe construction work zone implementation in that area. And because of that, Indiana Department of Transportation gave a project to Purdue to start construction, basically developing the optimal construction schedule to minimize the business impact in that area. So how we can schedule the road construction projects in the given urban area with minimizing the business impact, as well we consider the holistic effects due to interdependency between the projects. So these projects also they are carrying out in different parts of the network because of the road choice of travelers, the traffic flow in the system, their travel time on the links and also in the network would impact each other. So when we are going to schedule this project, we have to consider them simultaneously as well. That was one of the challenges that we had with the Indian practitioners, because they were thinking that why we are doing them at the same time, why we are doing the simultaneously road construction scheduling. So here's the literature review. Of course, the literature, the project duration are the short term and the long term. There are different stakeholders that they consider. Our paper falls in this area. In the long-term project duration, the duration of this project here in this part of the research and the presentation is like few months. We use the active set algorithm, unlike all the previous studies in this domain that they use meta-heuristic methods. There are two types of project, road rehabilitation and capacity expansion. We formulate as a bi-level model, and we consider the capacity drop during the road capacity expansion project and road rehabilitation. Unlike previous studies that they only consider the capacity increase after the implementation of these projects. So we develop a multi-period, so we divide the construction horizon into multiple periods of like few months duration. And then we have two criteria, minimizing the effects of construction works on total system travel time and business revenue in surrounding communities. So we consider both capacity reduction during the project implementation and capacity expansion after the project implementation. And we account for project interdependencies. And one of the things that interestingly was dominant in the literature was they consider only one period for implementation of this capacity expansion project, while we consider multiple periods, and there is a flexibility for the agency to consider multi-periods in that regard. We adopt the active set algorithm to provide the optimal solution in a finite number of iterations. So please note that this optimal, I don't mean that the global optimal, the problem is NP hard, it's very difficult to solve. So global optimality cannot be guaranteed, but the good thing about this active set algorithm is that it has been shown mathematically that it can yield the local optimal solution, a stable one in finite number of iterations. Okay. So the construction horizon is divided into T periods. Each period has a duration of few months. The planner aims to optimally sequence project to minimize total system travel time and business disruption costs. The construction projects have to be completed before the end of the horizon. So the construction horizon is fixed like 2 years, and the project have to be done within that time duration. So it cannot be extended beyond that. The domain of project types are like capacity expansion of existing links, like this one. So during the project construction, there is a drop, and after project construction, there is an increase in capacity of the road. And road rehabilitation, where during road rehabilitation, the project, the road capacity is dropping, but after that, the road capacity is constant, similar to before implementation of the project. So we formulate the problem as a bi-level model. There are two players, agency and the road users, traveler. So agency is going to decide about the project scheduling, and in another research we consider the project selection. System level goals is like minimizing this business impact, the total travel time of the road users, and if needed, the construction cost of the agency. And in the lower level, we have travelers who are going to react to decisions of the agency in terms of the road construction works on scheduling by making the road choice. And this network travel time and network link flow, they are going to fit into the upper level. And these two levels are going to interact with each other. And if we solve them simultaneously, we get the optimal solution. So we solve it using the active set algorithm. And here's the schematic figure of active set algorithm. The idea is simple. So active set algorithm is going to fix the schedule of the project. So to 0 and 1. If you are going to start at a period like T, it's putting at 1, it's fixing at 1. If we do not start, it's going to be fixed at 0. Then it's going to solve for the lower level, the road choice of the travelers, travel time, networking flow, they are going to be derived. And then it looks into the Lagrangian multipliers of these two constraints. The constraint, not these two, they see these many constraints on the scheduling. So if, for example, it finds out if the a schedule is going to be flipped from 0 to 1 or 1 to 0, it can reduce the objective function further. It's going to flip them. And this process of flipping is going to be continued until it converges to the optimal solution. So we apply this to the famous two-pulse network. Here are the links slated for capacity expansion, links slated for the road rehabilitation. And we looked into the impacts of, we looked into many things, but for this presentation, I put this as one of the results, which we looked into the impact of weight of total travel time on the optimal total system travel time and the business revenue. So in this graph, you see that as the weight of total travel time in the objective function increases, the business revenue reduces. And the total system travel time, of course, reduces because we put higher emphasis in the objective, in the optimization framework, which is very important finding. So it means that if you increase the network mobility, it doesn't mean necessarily you will get a you will contribute to the businesses in the neighborhood communities. So you have to look into the problem in much broader aspect. And this graph shows that if, for example, agency was only looking at the minimization of total system travel time, he would hurt the businesses in that area. So he had to basically look beyond that and put the emphasis also on the business revenue in the objective function and solve it. Similarly, for the value of time. So if you put the weights equal and solve based on different value of time, you see that basically it's similar to the previous one. As the weight of total travel time of the people increases, the business revenue will also decrease. The total system travel time, of course, is also decreasing because we put a higher weight on that. So next, I'm going to speak about the second research that we did in this domain about the bundling construction projects in urban road project scheduling. So the findings have been published in contract bundling consideration in urban road project in computer-aided civil infrastructure engineering. So here we look into the transportation agency and road users as stakeholders, the road capacity expansion and road rehabilitation for the project type, and also bundling these projects. So imagine that we have both road capacity expansion and road rehabilitation on the same link, and if there is a possibility to bundle them together. So there are three options. There are two options. So basically doing the road capacity expansion and road rehabilitation, or bundling them and doing them simultaneously. And meta-heuristic method, which is the non-dominated sorting genetic algorithm, is used to solve this problem. So why bundling? So bundling is a method that has been shown that if, for example, agency is going to group multiple projects into the larger contract, it helps to mitigate the budget restriction by reducing the cost of the project. And it shows basically based on the report by US Congressional Research Service in 2018, it yields economic efficiency due to economies of scale. But the question is that why not bundling all road projects together? Because if you make it a larger project, then you have to fully close the road. And if you fully close the road, it has a higher impact on the network mobility compared to when then you partially close the road and let the people to use the remaining road space. So there's a trade-off here, similar to the previous research, how to optimally bundle and schedule the road construction project to minimize the adverse effects subject to budget restriction for transportation agency. Another aspect that we looked into in this research is this pausing the project. So sometimes the agency has to pause the project due to the extreme winter condition, extreme weather conditions like tornadoes, also like Olympic games, sport games, and so on. So what if we have to pause the project for some time and then we continue after that? And that has also been captured in this research. Here's the position of this paper in the field. So it's like a network-wide paper, base level paper. In terms of objective, we consider total travel time and construction costs. We do the project scheduling and bundling, and time discontinuity in project implementation is also captured. So we develop a framework that considers project bundling in the design of optimal construction schedules. It enables the road agency to address twin objectives of reduced construction costs and reduced users costs. It's solved using a non-dominated sorting genetic algorithm, which allows the agency to basically select the optimal solution based on its own preference, as it provides for us a Pareto frontier. So we consider the existence of implementation time gaps during the construction horizon, which if we do not consider that, and if the contractor or designer in the practice wants to implement the project and pause the project, we are going to give to him the suboptimal plan, not the optimal plan. And because of this suboptimality, you see that the higher total system travel time would be observed. So the structure is pretty much similar to the previous part of this presentation. Instead, we have the possibility of bundling this project together. We have multiple projects on the same link. And here we also have the construction budget and project completion constraint. The objective is like construction cost and system travel time. So we applied this framework to Anaheim network, and the links slated for construction projects are shown in the dark black arrow. So the construction horizon here, we assume that it's ranging from June 2019 to August 2020 into 6 periods of each 3-month duration. The reason that I'm basically focusing on date here because I assume that the road projects are paused during period 4, December 2019 to February 2020, due to the winter weather condition. So the seasonal adjustment factors are borrowed from Indiana Department of Transportation, and value of time is assumed to be equal to $20 per hour. So first, you see that in period 4, we do not have any project. And oh, I forgot to mention that basically this is the optimal schedule when we consider only total travel time and when we consider only construction costs in the optimization framework. And the project 1 is the road capacity expansion, project 2 is the road rehabilitation, and project 3 is bundling. So here you see that in the left schedule, when we consider only total travel time, the system is trying to do this project more of separately rather than simultaneously. But some of them, they are going to do that in bundling. They are going to bundle together because of the budget restriction. On the other hand, if we only consider the construction cost, most of these projects are not most, actually all of them are going to be bundled together because it results in the lesser construction cost for the agency. So these figures show the comparison of construction cost, total travel cost, and total cost under bundling and no bundling plans with different construction cost rates. So you see that when we actually the bundling here on the left side, when we do not have any bundling independent of the objective function, whether we consider only total travel time or only construction cost, does not have much impact on the total travel time. But when we are going to construction costs, it has a huge benefit in terms of construction costs. And because of that, when we look into the total cost, whether we consider bundling and only total travel time or only construction costs, we do better. The system performs better compared to no bundling. But when we consider only construction, basically when we consider only total travel time, here is the better result. When we consider construction cost, also it's lower here. It's a bit higher compared to the plan that only consider total travel. So value of time. So let's look at the impact of value of time here. So when the value of time increases, the total travel cost increases because of total travel cost is the multiplication of value of time and total travel time. But also the construction cost increases because when the value of time increases, the agency has to put a higher emphasis on the cost of travelers in the objective function. And then because of that, the construction cost increases. There is a drop here from value of time 9 to 11 because when the value of time increases, the agency relaxes this bundling. So when we are going from this point to this point, there will be lesser project bundled together. And also the value of time increase from here to here. Since the total travel time reduces, we see a reduction in here. So the third part of this presentation is about methodology for scheduling within the roadway work zones using deep neural network and active learning. This research just got accepted in Computational Civil Infrastructure Engineering in 2022. So here the emphasis on the short-term road projects, the project that takes like few hours, like guardrail repairs. Unlike the previous part of this presentation, where we consider a long-term road project in terms of multiple months. So traffic is, we aim to minimize the traffic disruption and the project-related cost. So in all parts of this presentation, there is a trade-off exists. And the trade-off that we have here is between the traffic disruption cost and project-related cost. Why is that? Because if we do the this like guardrail repairs, it is minor road projects, sewer fixations, and this kind of small repairs, if they happen during like the working hours, peak period especially, it has a higher impact on the network mobility. While imagine that if they are going to be carried out like 7 p.m., it has a lesser impact for the travelers, while the agency has to put higher wage costs and labor costs because these projects are basically going to be implemented outside of the working hours. And because of that, there exists a trade-off between the cost of agency and travelers. So the stakeholders are like transportation agency and road users. The project types, we consider minor road project here, and we use the meta-heuristic neural net. So if you look at the area, basically this area, especially short-term road project, they are either corridor level or network level. But even though that they are considering the bi-level framework and the road choice of the people, they use that using the simulation. They didn't use an analytical tool like dynamic user equilibrium that we have in the literature to capture the road and departure time choice of the travelers. So it's a bi-level model. The stakeholders are system operator and road users, and we use the active learning ensemble with neural network. And we apply the dynamic traffic assignment. So here the research contribution. The network-wide road project scheduling is modeled using an analytical approach instead of simulation. The DTA model proposed by Han et al. Is extended and used in this study account for capacity modification and demand heterogeneity. And due to the inefficiency of traditional materialistic to address this problem, we use the novel machine learning approach to reduce computational time significantly. So the network-wide optimization framework of this study gives consideration to the goals of both stakeholders like road users and city agency. And by considering the impact of time, the proposed model strives to capture the trade-off between the city agency cost and road users cost. So here's the structure. Again, we have the bi-level framework, and the upper level we have like true cost, the decisions, and the constraint that's related to the agency. Road project starting time, the goal is minimizing the total travel time and city costs and the normal constraint. When we are going to the lower level, we have the departure time and have choice of the travelers. So the departure time is the unique feature that we have in here. Previously, since we only have the road choice, we were using the static traffic assignment, but in here we have to use the dynamic traffic assignment, which itself is very difficult to solve. And use the deep neural network and some of the active learning algorithm to solve this problem, and then apply to the pulse network. So we compare the performance of our proposed algorithm with non-dominated sorting genetic algorithm and particle storm optimization. And here's the performance of this machine learning algorithm. So you see that our proposed algorithm is yielding the result in the short-term time duration, like 8 hours compared to like 40 hours, and in lesser number of iterations compared to the genetic algorithm and particle storm optimization. And here is the Pareto plot, the eventual Pareto plot. again, we see the impact of value of time. So as the value of time reduces, you see that the construction cost for the agency also reduces. Similar pattern that we see also in the previous parts of this presentation. And why I dwell so much on the value of time in this presentation? Because if I want you to have one takeaway from this presentation is this, because if the value of time reduces, it would be very beneficial for the agency, because he can put a lesser emphasis on the total travel time of people. And how this value of time can be reduced? The emerging technologies like connected autonomous vehicles. The people can work, they can sleep in their car, they can entertain themselves, and they can spend their time for the other tasks. So the value of time is going to be reduced, and this will be beneficial for the agency. So let's see some concluding remarks. So in this presentation, we saw the different frameworks considering different real-world aspects in road project consideration and in road project scheduling, like business disruption cost, project bundling, project with durations of few hours. These are all formulated using a bi-level framework, and we apply different algorithms like active set algorithm, non-dominated sorting genetic algorithm, and deep neural network, and active learning algorithm. So emerging technologies such as autonomous vehicles, by reducing the value of travel time, could lead to overall cost saving in construction costs for agencies. Restricting the project schedule to limit the business impacts in certain neighborhoods can rather significantly increase the total travel time. By considering business disruption costs, the optimal project schedule significantly reduces the business monetary losses due to construction works. And for projects slated for bundling, if we want them to be beneficial for the people as well, we should avoid complete road closure, because this complete road closure will have a higher impact on the mobility in the system. So if you would be able to do the bundling and go with the partial road closure, it would be much better in terms of the objective function, and it enables to further reduce the total construction and system costs under the optimal scheduling of construction work zone. So future research direction. So here we only see the two players, agency and travelers, but there are also third player, the contractor, who is going to implement this project in practice. So he or she will have its own consideration. The project implementation needs resources, the availability of resources. Sometimes even the resources are not available at that time. It has to come from other states. That takes time. So these are all at the planning level. And by agency is going to be driving. When we are going to the third and fourth level of the cycle for infrastructure, like design and construction, we have to consider the tri-level structure. Agency, contractor, with its own constraint, with its own objectives, and the travelers. So the tri-level model is more appropriate in this context rather than the bi-level model. So we consider deterministic road project cost and duration, which of course it's highly ideal. It won't be happening in the practice. The road project cost is highly uncertain. The duration is highly uncertain. Because of that, these many issues like cost overrun is occurring in practice. So we have to develop a model that would be able to capture this uncertainty in the framework. So we consider the scheduling of road project in discrete time setting. We discretize the construction horizon, and the continuous time setting is another approach. Bundling road project across links. So what we saw here is bundling road project on the same link. But how about if we bundle the project across links in the network? And capturing other aspects of emerging technologies on road project scheduling. So what we saw here, just I mentioned about the value of time. It won't be only impact of the emerging technologies like connected autonomous vehicle. on the transportation infrastructure. We will have several other impacts like capacity improvement, road capacity improvement. They have a lesser headway, they can travel closer together. Because of that, we have a capacity increase. Or induced demand. We will have induced demand, we'll have higher demand when we have the connected autonomous vehicles on the road. So we can't conclude based on the value of time that the autonomous vehicles would be definitely beneficial in terms of the construction cost for agency, but this aspect of connected autonomous vehicle would be beneficial for the construction agency. And before I adjourn this presentation, I would like to thank Professor Krieger. I'm not sure if you know him. He was a professor at Purdue University. He helped us in the bundling project. He was a great mentor. He just passed away a few months ago, and I would like to just thank him for his feedback. Here is the last part. So the last part of the presentation, basically the papers that we do is on the evaluation of the full and partial link closure option for urban network growth projects. So I just skipped that, but if you are interested to also hear about this part of the research, we can stop by our poster presentation during TRV. So thanks for your attention, and I would be happy to hear your questions and comments. Thank you.
Thank you. Thank you for the nice presentation, Professor. I have two quick questions. First of all, out of curiosity, when you mentioned that the car dealer sued, I don't know, Department of Transportation, was that considered as an externality, and did they actually win it or not? The second question is on the first problem. You mentioned that it is NP hard. Like, how did you prove that it's good? One of the well-known NP hard problems.
Sure. So for the first part of the question, they reached an agreement. They reached an agreement that they promised that they are going to study this problem, and that won't happen in the future. And later we didn't hear any other complaint from Barbara. It's the biggest car dealer in that area, biggest car dealer. And the second part, basically, it doesn't need to be proved actually mathematically. It's well known that the bi-level model, I didn't basically put the mathematical format, but go to the structure of one of them. So since we have project selection and scheduling, which is integer, and also we have the lower level, which is the user equilibrium, which has a complementarity formulation structure. This bi-level is NP hard. So these two together is sufficient to have the NP hard problem. So any of the results that I have shown here, we try to use the enumeration technique to make sure that basically we got an optimal solution for one of them at least. For NP hard problem, we cannot guarantee the optimality. The local optimal is the best. Thank you.
Professor, I'm curious to know how, I think on slide 32, you mentioned that they chose, or you selected a value of time of $20 per hour, I think.
Which one? This one? 32?
Or for the second paper you presented, there is the value of time. I thought it was selected, but why was it chosen to be $20 per hour?
There was some reports that we looked into from like Oregon Department of Transportation, the US Department of Transportation, and 20 is reasonable value. It's not like that I can say that there's one value. It's a range like 15 to like 25. So we just chose 20.
And how is it that this value is being
just basically looked into the reports for the value of time. But then we did a sensitivity analysis, a lot of sensitivity analysis on the value of time.
Okay, maybe what I'm curious about is how autonomous vehicles are gonna affect the way we compute the value of time. Because as far as I understand, it's dependent on people's average revenue. And I'm not sure how that's gonna go into.
There are several studies. Actually, if you want, I can also send you the references that shows that because the travelers spend their time in the vehicle on other aspects like working. They right now your time in the car is like wasted time. But at that time, you would have production. You can sleep, you can eat, you can entertain yourself, you can do your job, normal job that you do. So that won't be anymore a wasted time. That's why it says that the value of time, that value of travel time is going to be reduced.
I can ask one. Yeah, great presentation. Thanks. Really interesting topic. I was wondering about this value of time issue. Did you look at any of the economic effects, perhaps on other industries, like, for example, hotel industry might suffer, right? Now you can sleep in your car. You don't need to maybe get a room for the night. You can just, for example, you came here from Chicago. Maybe you could have left even a few hours earlier, took a nap in the car, right? Things like that. Have you looked at the economic effects or talked to any economists about that?
Nice suggestion. Actually, I was a postdoc at Center for Connected Autonomous Transportation for like 3 years, and that's a very good idea. I haven't thought about that, and I didn't see any project also in CCAT on this. We were almost looking in the traffic flow, how the design of transportation infrastructure. We didn't go to the other industries, like what you mentioned, the hotel industries and so on. For example, one of the, in terms of transportation, we thought about this. There are so many papers is publishing these days on parking. So the car can roam in the city. You can just, for example, when you want to do the shopping for 1 hour, you can just send your car to go around the city and come back in 1 hour. Or, for example, you can send your car to the suburban areas. So it has been a study in transportation context, the impact, but not in like the whole. I haven't seen it, at least in CCAT.
I'm not an economist, I can't do it, but hopefully
That's my
somebody,
suggestion.
yeah, hopefully somebody. can work on it.
Yeah.
I had another question. In the first paper, I think it's like 22 and 23. I was curious to learn how, or to know how the business revenue is estimated or predicted.
Okay, so that was the difficult part of that study. So for that, we went to the businesses around the city in Lafayette and asked them how much they were making before and after the before and after the project implementation. And then we got an average, and then we came up with this average for the customers that then we assume that, for example, certain percentage of each traveler between each auditor is going to shop. And using that, we came up with the optimal schedule. Thank you. Yes.
Sure, I'm sorry, I didn't have a lot of time to focus on your plot on slide 44, where you were comparing your model to 2 other machine learning models.
Not the machine learning, the material, they are materials.
Yes. Can you please explain which is which, and
Sure.
how can you tell which is better?
So this deep neural network ensemble the active learning algorithm. So you see that there are fewer number of iterations in this one compared to non-dominated sorting genetic algorithm, NSGA, and particle store optimization, this one. And because lesser number of iteration, it would be able to give the results in like 8 hours compared to like 41 hours for each of these NSGA and particle store optimization.
Only comparing the running time, or is it also comparing?
In terms of the accuracy of the result, you can see in here, there are not much difference. They are all heuristic, they are all heuristic. We try to check the result as much as possible with enumeration technique. But we couldn't do that for every point and every analysis that we are doing in this presentation. So you see that still basically the active learning algorithm is doing better compared to the other two, like in circle and like in multiplication. So this one is doing better, but the result is not that different. Here the efficiency is much more significant. Yes.
The question was me.
Sure.
Asking, do you think the value of time is actually for evaluating user costs? There has been a lot of discussion on treating human time.
As
Uh,
so, what are the other suggestions besides? So, what we consider here is like total travel time multiplication by value of time. So, what other factors he has in mind?
He just wanted your perspective.
So, of course, basically, travel time cannot be only proxy in the road choice of the people. So, this question can be extended beyond the scheduling. So, for example, you may want to avoid the arterial, for example. You may want, for example, to go shopping somewhere. So there are so many other aspects that you will come up with the road choice, but I'm not sure what specifically he has in mind. But of course, basically the total, we consider the total travel time multiplication by value of time as a cost of the travelers, the road users.
Well, I didn't have anything in mind. Hi, sorry. Can you hear me?
Yes.
I've been involved recently in some discussion on how it may not be a good reflection of somebody's time to just say, my time is worth $20 an hour. So I just wanted to get your perspective on that. Like, I didn't have any points on what a better thing might be, because I'm not sure if we have a better thing. I just want to get your perspective.
Of course, basically, I also agree with that person. It might not be the best, but basically, this based on the scope of this, basically this studies based on construction scheduling. Of course, no model is perfect, but some of them are useful, and the value of time was very helpful in capturing the travel cost of the people for us.